Today we're going to be talking about 1-9 and our learning goals for this lesson. Our learning goals are to transform some lines. By the end, you should be able to describe the effects of a rigid transformation on a pair of parallel lines, as well as if you have a pair of vertical angles and know the angle measure of one of them, you can find the angle measure of another. Let's start this activity by doing 9.1 in your workbooks. This should take a couple minutes for you to describe a translation, rotation, or reflection that takes line L to line L prime, and then plot and label A prime and B prime, the images of A and B after that transformation happens. You need to do that for both numbers 1 and number 2. Please pause the video and complete the task. You can now see that we're going to translate A and B down onto line L prime, and that would be our A prime and our B prime. Here's a line of reflection, and then it would just be reflected over that line, creating A prime and B prime exactly where they were when we translated. And you also have the option to have a center of rotation directly in between either of your points, but this would rotate 180 degrees on top of each line. Okay, you could start in this other figure with a center of rotation at A and take line L and rotate it clockwise, the obtuse angle on A. That's counterclockwise to B prime. You could also go clockwise, the acute angle, and there would be your B prime on line L prime. We could also draw a line of reflection to show reflection, and you would reflect across the vertical line going through point A, or you could have the horizontal line through point A be a line of reflection, reflecting the line on top, and there would be your B prime. A prime would stay exactly where it is right now because the center for your rotation is there, as well as your lines of reflection intersecting there. In this image, I rotated parallel lines A and B around this point K right here. And when they were rotated, you can see they went 90 degrees. Okay, so A rotated 90 degrees about this point, and you can see their lines. This is your B prime line right here, and this is A prime line right here. So when you're working through these problems, you really need to think about what happens to a set of parallel lines when they're transformed. Well, it looks to me like now they are perpendicular, right? So let's start to discover more. So in the first problem, it asks us to translate lines A and B 3 units up and 2 units to the right. So you can see in this first one, I have my 2 lines here. So what do you notice about the changes that occur? Well, in A, B, A prime, and B prime, you can see that all of these lines are parallel, and that the lines A prime and B prime look like A and B but shifted upward, which is exactly what happened. Those lines all remained parallel and they did not change. And the image that you see now is after the rotation of AB around K. You can see that line B is going to remain as B prime, or it's going to turn into B prime, and A is just reflected across that line. So what do you notice about the changes that occur to lines A and B after the rotation? Well, the new pair of lines A prime and B prime are still parallel to the original lines A and B. That hasn't changed. And what is the same in the original and the image? The lines A prime and B prime are still parallel, and they are the same distance apart as A and B. So the distance between them doesn't change. Make sure you're recording this down into your workbooks and not just listening to the video. Make sure that you're seeing the same things that I'm seeing. In this last transformation, you were to reflect lines A and B across line H. For letter A, what do you notice about the changes? Well, the changes that occurred is that line A is above line B, whereas line B is above line A prime, line B prime is above line A prime, but it keeps that distance, right, when we do the line of reflection. What is the same in the original and the image, so the pre-image and the image? Lines A prime and B prime are still parallel and the same distance apart as lines A and B. So all 4 of these lines are parallel to one another. Again, always make sure you're using your patty paper as you're going through this so that you can actually transform the images. Keep practicing with that patty paper. So from what we learned yesterday, when we rotate this around A, C, D, and B, we're going to rotate around point D 180 degrees, it looks like. So remember how we did yesterday, that they just moved over to the other side and we're still the same distance. So here you have your DB, and we're going to go the same distance over here, and this is B prime. Then we're going to measure from C to D, and we're going to go the equal distance on the other side because that would be our 180 degree rotation, and we get C prime. We're going to do the same thing from A to D and D to A prime. And there are 3 points after the 180 degree rotation around point D. This would be the order of our points. Okay, so the diagram shows a line with points A and C on the line and a segment AD where D is not on the line. We're going to rotate the figure 180 degrees about point C, and we're going to label the image of A as A prime and the image of D as D prime. So as we're going through this, when we rotate, we have to remember to use our patty paper, and the distance from A to C should remain the same. However, it should be on the opposite side of the line since we are rotating. You can see that angle CAD and angle CA prime D prime have the same measure because both distances and angle measures were preserved under the rigid transformations we performed. This diagram shows two lines L and M. You can see that I'm going to rotate around O, and if I had patty paper, this is what would happen after the rotation. My D prime would be the equal distance from O. That's what we talked about yesterday on 1.8. Same thing for A. It'll be equal distances once I rotate 180 degrees around that center of rotation to A prime. Once I have those, here you can see that each of those rotations is 180 degrees. Angle DOA is going to be congruent to angle D prime OA prime, and angle DOA prime is congruent to angle D prime OA.